Hello everybody. Let's see if I can do this. Please feel free to tell me if anything is too loud, too quiet, whatever. It's the first stream, so be supportive. Seeing some appreciation for the cows, which is awesome. Quiet person, oh no. I sound good, thank you. I'll turn myself up a little bit for Omni Technomancer. How's that? Great. Okay, so today we're going to play with a Glasgow. So I've got one just here, and I've got all my toys, so I'll get some of them out of the way. So we've got a Glasgow, and we are going to play with some of the applets which they have. So today I'm going to look at converting the PS2 host applet to nMigen instead of nMigen.compat, which it's currently using. So here I've got a PS2 just to standard sort of 0.1 inch pin header. I've got my PS2 to USB adapter, which goes in there, and then I've also got a USB mouse. And I'm really hoping that this actually works out because I haven't actually tried this mouse with PS2 before. So let's just hope, shall we? Right, so let's bring in some USB. I've got a little board here, which I made a little while ago, which will allow us to press the button here to power cycle the device, which is in this case the Glasgow. Let's just turn that around, there we go. Okay. So with the push of a button I can power cycle that Glasgow, and if necessary we can do things like that. Some stuff I've been playing with in the past, I've got an I2C pressure sensor here, which I just played with to get the, the script example up and running, so that you can write a Python script and then just use the applet from Python basically. You don't have to worry about writing a new applet or anything. Oh yeah, the switch is cool, thank you. It's also got probe points for the D+, D-, and if needs be you can also attach to these little pins here with little grabbing hooks to take control of that power basically. Something else we got is a chain of, I think these are neopixels, is that what they call them, Adafruit? So again, I was converting the, not what it's called now, it's not DS, but WS 2818, something like that? Yeah, exactly, 2812. So we could get them up and running if people are interested in seeing, but that's not really the focus of today, I don't think. So hopefully I won't knock things around too much. Something like that, yeah, I can't remember the precise number. So hopefully you can all read the screen okay if I show it like this. So if we come into here, there you go. It's interesting about the clock versus I don't know what to call it, but it's kind of PWM, it's not really, but you can drive them from a SPI peripheral, but you need to be quite careful about laying out 1 byte per bit transferred. But yeah, anyway. So I've been working through the list of applets. White Quark's drawn up a list on the Glasgow GitHub, which I shall just grab quickly. Issue number 150. Oop. So we're working our way through these applets which want to be converted to nMigen, and currently I've done the audio DAC is actually pretty cool. just by wiggling a digital pen really, really fast, you can actually hear some pretty high quality audio. I love that. We've got the SPI controller, which I haven't looked into. There's actually some note down here about extra things that need to be done relating to that. I've done the UART, that's a PR in progress. And now today we're going to have a look at the, I can't see it, PS2 host, and possibly if we have time we'll have a look at the VGA output as well. So the PS2 host, let's have a look at how that might work. We've got interface.ps2 host or something else. Oop. Sensor mouse PS2, that sounds quite good. PS2 host. Let's have a look at that then. Right, so this is where we have to start looking at hooking things up. I can never remember, I'm pretty sure that PS2 is 5 volts. Anybody care to chip in? Aside from that, we've got ground data. My breakout's rubbed off a bit, but I think I'm going to go with a clock being on that last pin with no label anymore. Right, so let's try and hook that up. We've got default of pin 0 being the clock and pin 1 being the data. So at the moment I've got ground is purple, VCC is green, so I'm just going to hook them up quickly. Ground is purple, VCC is green. Oh, wrong side. I'm used to having this the other way up, you see. I think that's correct. Green is VCC, ground is purple, yeah. And then we've got the clock is going into pin 0, which I think will be grey. And the data, which is currently connected to blue, goes into pin 1. Alright, how's that look? I think that's okay. Cool, okay, let's stick with 5 volts. I might just confirm that quickly. So PS2 connector pin out maybe. So we've got data and clock, and then we've got pin 2 and pin 6 are unused, so they're labelled, and then VCC is 5 volts at 275 milliamps, and I expect we'll be well below that with a nice modernish mouse. Okay, so let's see if this works. I'm not quite sure how to drive this, but we've got the sensor mouse PS2. Maybe let's get the hub for that up, see if that gives us a little bit more details on what's going on. Oops. So stream log, stream new input. Okay, so let's get a log out. Let's go for the pins in the standard place. We don't need to specify them. Volts, 5 volts. What else do we need? Just go for it, I think, see what happens. Timeout, connection problem, question mark. Oh no, oh no. Let's see if we get any lights or anything on the mouse when we power it up. Nope, nothing at all. Just take this and have a quick look. So we've got ground purple VCC green, ground purple VCC green, looks good. And then data blue, I'm presuming clock grey. That looks okay. So then, why is this not working? Connection problem. Let's give a rate out and see if that helps. So sample rate of 10 perhaps. I don't think it probably will. This might be a very short stream. Things getting too warm, no shorts probably. No. Oh dear. Any ideas, anybody? Tell you what, let's just get a logic probe and see what happens from there. Omni-Technomancer, are you talking about the Glasgow supplying power? Let's just get this out quickly and then we can pop the lid and just check everything's okay on the inside of the mouse. Very possible I've connected things incorrectly. Unfortunately, I don't have a camera that's sort of here in front of me. I could just show you my big face if you like, and then try and hold it up off the desk a bit. There you go. So like always, these modern mice are just ridiculously optimized. There's an LED, a single chip, mouse wheel with optic sensors, 2 buttons, and that's it. So if we go for some tests, give you a view of that. I'm going to guess that black is ground and red is 5 volts. That looks good. And then the 2 signals, 0.15 and 3.7-ish. Let's try turning it off and then stealing the connector here, just so we can identify which is which on the board, because there's no labels inside the mouse. Actually, I'll just take the whole thing. Excuse me. I'll put that into continuity mode. Got that chappy there. It's VCC. That one there. Ground. And then we got white. He's got the memory here. White is data, and green is the unlabeled one, which I think is clock. So green is clock. Let me write this down, otherwise I will forget. So PS2. We've got green was clock, I think it was. Lab notebook, definitely. How can people survive without them? I actually, literally, this is page 2 of my new notebook, and I'm very upset that the new book doesn't have a margin down the side. Not sure if that's a controversial topic or not, but. Yeah, so data is white. Therefore clock is green. And we've got clock, data, 5 volts, ground and I think a shield on a 5-pin connector in there. So I'm just poking up against this connector here. Yeah, this is a very good idea. If I had a computer with PS2, then that would be great. Unfortunately, I do have a computer with PS2, but it's not one I can reboot, and the fact that it doesn't have a mouse connected at boot probably means that that port is not going to work from previous attempts at this kind of thing. So that's very frustrating. Let's just lose the lid of the mouse. What else we got? What we could try doing is looking to see if the scroll wheel just comes out. Looking to see if the chip has any markings on it. The optics come away, but I suspect no discernible markings. So this is a Logitech B100 mouse, and it is listed on their website as being USB, as in a hard requirement that it has a USB port. So I wonder if this doesn't support PS2, which would be quite frustrating, but also a little bit surprising, to be honest. If I can figure out how to get the scroll wheel back in. No screws, that's a nice construction there. Looks good. Thinking about it, I do have a USB to PS2 adapter somewhere, in one of these boxes. Let me have a quick rummage. Oops. I think it's probably not in here, which is annoying. In terms of old laptops, unfortunately, I don't have one handy. So that's quite frustrating, isn't it? There we go. I'm going to suggest hooking up the logic analyzer and just see what happens. If there is any kind of response, if there's kind of a no-go away type of thing. It does say, if we look at the error message, that there's a timeout. Yeah, they are usually PS2, I think, for quite a number of years. Have a think. So I have a headless Linux system which has got that PS2 port I mentioned earlier, but I would be surprised if it sprang into life. A clock from the device. Ah, okay. I thought it was driven by the host. Well, that would explain why we're seeing a funny small voltage, wouldn't it? Let me just get a little attention and I can keep this all in shot. I hate boxes of wires. There we go. One is free. Alright, let me just plug this in. Okay. What do we reckon? Are we going to get a nice green light on the... or red, sorry, red light on the... 3, 2, 1. No. Be silly. If I could reboot that system, I would, but unfortunately, not allowed. Okay, about the clocks. That's interesting. I should probably have given this a go earlier, shouldn't I, really? Bit of preparation for the stream. Alright, let's go for 3 of them. There's a hash on the chip. Part number? Unfortunately not. It's probably going to come way out of focus now, but it's clean on the top side. There are some holes, but no part numbers, and on the bottom side it's clean as well. So unknown chip there, but the mouse is, if you want to have a look at that, is a Logitech B100. So that could be interesting potentially to look up. Right. What do we have then? Let's go for clock on channel 0. White Quark actually showed me the other day that there's a trace utility or function built into Glasgow, which is awesome. I gave it a quick go and it is really awesome, but unfortunately I just find the discrete logic analyzers is a lot easier to deal with, more user-friendly and things. So I'm just going to stick with that, I'm afraid. Grab each of the pins that we're after. Nice black wire. How's the levels, by the way, everybody? Is the music and my microphone, everything okay? Oh, cool, thanks for looking it up. Definitely worth doing. It could be the adapter, actually, thinking about it. Oh, I've just removed all of them. Sounds good. Yeah, that's awesome, thank you. Let's try and hook these up again. The green is VCC. Purple is ground. That leaves clock and data as grey and blue. Okay. What do we reckon? Are we going to see anything on this? Does the chip look like this? Let's have a quick see. Yes. Oh, do you reckon there's a very faint marking on there? I can't see any evidence of that laser etching or the laser marking on this right hand side here. But there is a hole which looks very similar to that A. It's just on the wrong side. Rotated. Yeah. Happy to get some extra light. Just climb forward on the desk. Oh, that was... Okay. Not expecting that. So, what do we reckon? Where's my loop? Okay, I'll read it out. You guys record it I'll write it down in the chat, that'd be great. So, Papa Alpha Whiskey 3526 Delta Bravo Dash Foxtrot, I think that's Indigo Yankee 2. And then the other number is Hotel 627 Golf Alpha 32 Charlie. Thank you, everybody. I'm pleasantly surprised. I am aware of looking at under and harsh light, but I wasn't expecting it to bring anything out, so there you go. Now, how does this wheel go back together? Like that, there we go. Okay. That was fun. Okay, so what does that mean? We have I'm going to go with H something something something. Oh, okay, maybe not. Not one of them. What do you reckon about the other one? That's potentially promising. I could have sworn, yeah, they go optical mouse sensor. I hate these datasheet sites so much. Wireless mouse sensor, well that's interesting. 352, 352, so that's not the right thing. Perplexed, yes. Oh, they're so annoying, aren't they? Where do you click? Where do you click? Anybody else found information? Let's put optical in there. Mouse. Optical mouse sensor. PAW 3526 dB. That does sound promising. 3526. 3523. 3526. Nope, it's not in the page one time apart from on the title and the search box. Three, 5, 2, 6. Nope. Oh, that's interesting. Ah, look at that. There's our mouse. What about PS2? PS2? No. Great. Rabbit ears and everything, yeah. Search for enough variants, there we go. 3515, 3526, so we're close. Shall we just go with that for now, I think. USB interface, any mention of PS2, what are the bets? PS2. PS2, oh, USB-D or PS2 mouse line. No other mention of PS2 though. Okay, oh, you got it, well done. Let's grab that. Oh, close. Can I just have the PDF? Oh no, don't want to do that. Download. Fill in the capture. Yeah, let's not do that. So, I think here, no, not that one. One of these pinouts gives you indication of whether or not it was. No, I think that's, oh, that's the wireless optical mouse sensor again. That's not the one we're after. Never mind. Let's presume that it is PS2 compatible-ish. Let's get the logic analyzer and let's start the applet again and just see what happens. What do you reckon? No, nothing. Is Pulse View compatible with the logic, the Saley logics? I had to go a while back and I had serious problems. I think the FPGA image or whatever it is that's inside them is a bit hard for them to get at, so they can't distribute it or something. Ah, okay. Right, let's try one other thing, which is going to be to swap the pins around. That's not what I wanted to do. Let's do pin clock is 1, and pin data is 0, and just see what happens there. And I think if that still doesn't work, then we probably call it on the mouse. We can have a look at converting nMigen. No, there's something else happened there. I think that's probably the same thing, isn't it? We can have a look at converting nMigen, but we can't verify it, which makes me a little bit nervous. I could go and grab one other USB mouse I have handy. Unfortunately, all of my mice are Logitech B100s because I'm cheap and I just buy them for my laptop and things. I'll be right back. I'm going to grab a different mouse from next door and see what that does. I'm back. Hello, welcome. So I've now got my partner's mouse. It's one of these ergonomic mices where you sort of hold them like this. And it is an Anker A7851. Let's see what that does. A7851. Does it do PS2? No mention on the page, but that doesn't mean anything really, does it? Unfortunately, I'm not really prepared to take this one apart, so I'm just going to plug it in, see what happens. Oh, another option potentially is to change this this green adapter, because they sometimes have been reported to not work properly, so we can give that a go as well, but I'm not sure, because this one's got a nice Microsoft stamp in it. Oh, we've got a light on this one, look at that. Means nothing yet, but we have at least got light. Let's bring you back onto here. Get that going and get this going, see what happens. Nope, let's try the other pin out. Oops. Just 100% sure. Oh, I found a 5-button mouse. There you go, look at that. So how does this work then? Whoa, look at that. Brilliant. Hey. Parity error. Okay, it's been a while since I played with PS2, so I've completely forgotten how it works. I would guess that the device sends a clock with a word. What have we got? PS2, do you reckon? No. Never mind. Yes, I think you're quite right. I can't remember who it was that said that the device gives the clock. I think that's 100% accurate, so let's stick with that. We can move the mouse around, and we can get buttons, left, right, middle. No scroll wheel. Oh, there's the Z. The Z is the scroll wheel. And then we get X and Y offsets. Oh, there is? Okay. Analyzers. PS2, I'll go one by one. Very good at misreading and missing. Oh, there we go. Well seen. So mouse and a PS2. Oh, brilliant. I think the framing might be a bit wrong there. Oop. Ah, look at that, brilliant. So, we can work on converting this to nMigen, sorry. Now, I would not call myself an expert by any means on nMigen, but I'm kind of picking up as I go, and I seem to be doing okay, I think, hopefully, fingers crossed. So if there's funny things that pop up, then we might get a little bit stuck, but hopefully we'll be okay. Just get this all into good position. There's the mouse with its nice swoosh on the side, look at that. And there's a Glasgow, there's my keyboard, let's do that, brilliant. Okay. So we're working to convert the PS2 applet, and there's also the sensor mouse PS2 applet. So let's have a look, see what we can find in interface. PS2 host, and then in here we've got a nice chunk of README at the top, followed by the host applet. And then the mouse is going to be somewhere. What was the mouse called? It was called Sensor Mouse PS2. Sensor. It's just going to be Mouse PS2. There you go. In it. Yeah. I presume that my cheapo mouse, I think it was £5 or something, just doesn't do PS2. I don't know if that's a cost-saving measure on the chip or something, but I don't mind. We've got something that works. That's the main thing. Right, so I don't think we've actually got any nMigen in the mouse sensor or mouse applet itself, so that's cool, we can just ignore that. Just focus on the PS2 interface, brilliant. I have to admit that some of the old interfaces, you look back at them and you think, how is this, has it gone away? Has it not around anymore? But at the same time, you look at things like USB and they just sort of magically work. Plugging a PS2 mouse into that headless computer down there, I think it's one of those situations where if you don't boot with it plugged in, it's just never going to work until you reboot, kind of thing. But anyway. Cool. So multi-reg is going to be converted, so we have a list of, let me just find that quickly, list of conversions between nMigen.compat and nMigen itself. We've got that here, just get OBS back, there we go. Now multi-reg becomes an FF synchronizer, and that allows us to have an input which is not on the FPGA or in the FPGA clock domain. It sorts out the nasty edges basically. Over there so I can still see it. I think I'm going to ignore proving logical equivalence if that's at me. So step 1, get rid of that because we're not on the compat anymore. Step 2 is libcdc ff. Oh, sorry, you're not watching the right screen. FF synchronizer. And then the sync FIFO buffered is going to be a FIFO, I guess. I haven't done one of these before, so let's just give it a whirl. Oh, we're not actually using that, so I can just remove that import. So that's nice to see. Now, the major difference between nMigen.compat, presumably that's a compatibility layer with nMigen, and nMigen itself, is that instead of producing a module subclass, you actually produce an elaboratable subclass, and then you produce an elaborate function. We then need a module, because we didn't subclass from module, and we need to give that at the end so that it's passed through. Right now, in terms of what we're actually presenting and sharing with other people is the interface, and here we've got a number of signals which we're sharing, I think. We'll confirm that in a minute. Oh, actually, let's just do that now. So the falling is used by anybody who uses the PS2 bus. They make use of bus stop falling, for example. And the same goes for rising. The clock input, do you reckon that's used by anyone else? It looks like no, so we can actually bring that to be internal to the class. Clock output, who's using that? Some other people are using that, so maybe we should leave both clocks. And the same again for the data in and out. Right, so let's leave all of them as global or externally accessible signals. Let's keep hang of paths and go from here. The cheap NAS is never going to work on PS2. Oh, USB in it, okay, well found. Thank you for going down the hole. Right, so the combinational logic, we just move it from self.com because we're no longer a module, we are an elaboratable class, and we now have to give that to the new module. In terms of all of these signals, I think they can just stay as they are, to be honest, which is pretty good. Self.specials becomes m.submodules, and multi-reg, as we were talking about earlier, becomes the, what was it, FF synchronizer. Hopefully I spelled that right. Yeah. The signals I think are the same, but we'll get a build error if it's not, so let's just leave that as is. Who needs a new project? Shotgun, not me. m.d.sync. So synchronous signals are advanced once every clock cycle. And I think we're probably done with the PS2 bus. Just have a quick review. Yeah. I think that's good. We can come back to it later if it throws any errors, but that's nice for now. Again, module becomes elaboratable. I'm really not very good at spelling, so apologies for reading it out in such a way. Elaborate, self, and platform. I don't think we have a real use for platform here. Now we need to hang on to the bus, so self.bus equals bus. Whether communication should be allowed or inhibited. Probe. So who makes use of these? This is the kind of thing I would expect. Yep, so that is used. That's used. That's used. Just looking for the highlights on the right hand side now. That's used as well. Yeah, there we go. The applets are usually pretty well laid out, to be honest, and they have that little breaker comment. I like STM32s, they're good little things. So what is a record? I don't think we imported that, and I don't think we imported it previously, so that's possibly going to be something that we need to have a quick look in here about. Record. I think it possibly becomes one of these. What do we reckon? I'm just going to go with it for now, see what happens. HDL rec import record. And usually it seems that the API, the arguments provided are fairly consistent between the two, but if it throws errors, we can come back to it. If it doesn't work, we can come back to it. Right, so signal max is no longer how that's done. We need to give it a range. Python ranges are pretty cool because they don't actually enumerate everything, but you can determine if a number, for example, is within the range. So that's handy there. Self.sync, that's m.d.sync. And now, okay, so these ifs are not the way we do it with nMigen anymore. We use context handlers, and I think that's the right phraseology. So with m.if setup, then we do m.d.sync plus equals bus data out equals frame raw bits. And again we do, so if with, that's supposed to be with m.if shift m.d.sync, and then we've got 2, so we can make a little array here. And I think those can just be copied directly. Get rid of this. Right, state machine. Again, we don't do it the same way anymore, so we need to do with, I keep mistyping that, with m.fsm, and then with m.state idle. I think that's right. Let's just get rid of this one, actually keep that in here. So in the idle state, we need to check, first of all, if we're enabled, then do this. If we're not enabled, do these other things. So we make use of same context handlers above, so with record still exists. Do you think it's an hdl.rec? Or is it actually as part of this import here? Right, I'll just keep going for now. So if self.enable, then we do some stuff. m.d.sync plus equals okay. Let's leave it for now, unless you felt like digging into it and telling me the answer. It might well be that actually let's just look it up. So we've got nMigen here. grep2 record. Where does that come out? There you go, so I think it probably is this record here. And we've got a compat layer as well somewhere. Oh, there we go. Let's have a look at this one, see what that gives us. They look similar-ish. I think they might be. Let's leave it as is. So I'm using record from hdl.rec for the moment, at least. Okay, so where we have next value, this is where previously you put it into a next value, so you give it the thing you're giving the next value of and the thing. In nMigen, you have to give m.d.sync, and then you do bus clock o.eq1. Bus clock o equals 1, for example, and bit no equals 0. That's the end of that. Now we have another if, so it's going to get very boring for everybody until we get to the moment of truth. Now, right, so I think actually this possibly comes out. Let's have a look at what prepare frame actually is. Okay, so that gives us a whole bunch of next values. That means that we can put this in here, put a star on the front to elaborate or enumerate them all, and we can convert all of these frame.start.eq 0, frame.data.eq data, frame.parity equals reduce operator.xor. Do you reckon that's still a thing? Data frame.stop equals 1. Right, I think that should be good. So these other ones, setup and shift down here, those are going to be combinational, I think, because they're not inside a next value. So m.d.comb plus equals setup equals 1 and shift equals 1. M.next is send bit. M.else next is receive bit. There we go. And then we have with m.else okay, I think that should be that state of the state machine. Let's just grab that comment so we don't lose it. And get rid of this. Done. Next. So with m.state send bit. Not sure if I should be talking to everyone through this, or if they've kind of got the flow. Feel free to let me know if you'd like more commentary or less commentary. It's all a bit repetitive at this point. Grab that comment as well. Oh, nice. Welcome everybody new. I've not been watching that, sorry. It's my first stream, as I might have mentioned earlier. Is there somewhere I should be watching? Is there a counter somewhere? Ooh, users, 23 users? I can't quite see. Never mind. Welcome everybody. Is there, for those who have done streams before, is there a place I should be looking for people joining and leaving and things? Welcome, you can procrastinate with us. Well, hopefully I'm being a little bit productive. Oh, glad to hear it. Thank you, Eston. Right, that's completely wrong. I was distracted. Next equals idle. It's really great, actually. I love nMigen. I've done VHDL and Verilog in the past. I kind of found myself comfortable with Verilog over VHDL, but nMigen is yeah, well done, White Qualcomm team. Just fantastic. So the next state is the receive bit, and we can see the end. That's nice. State receive bit. Pretty mechanical, yeah. Quite a lot of it, unfortunately. I'm not sure if it could be automated, or if, to be honest, it's going to be more effort to automate it than just do it. I've heard that argument about VHDL before, to be honest. I don't know. I can't comment. I'll stay out of that one. Ooh. What are we doing? Bit no equals 0. There we go. It's interesting. I did VHDL at uni as part of my course, and without getting too into it, I struggled big time with it, and I think a lot of it was to do with the availability of the lab and the teaching. Really, really struggled. But since leaving and doing things on my own, being interested and self-driven, whatever you want to call it, it's kind of changed things a lot. Understanding what a toolchain is and how it works and why you're doing these things is, I think, really important. Optical encoder? Is this as in, don't know what to call them. Not grey pattern or whatever it's called, but you're trying to sense position with optics. Right, I think that's that done. Woohoo! 2 spaces between modules. PS2 host sub-target. This one looks a little bit larger, but not too bad. Have we got any other modules after that? No, Glasgow applet. And then we're hopefully done. So this is the last module, hopefully, and then we'll be ready to give it a quick whirl, see if it happens. Quadrature, that's the word, thank you. Yeah. Right, so here we've got some new things introduced. We've got the in FIFO and the out FIFO. And this terminology and directionality comes from USB. So in is from device to host, and out is from host to device. So the in FIFO gives us an endpoint that we can write data into. And anyone familiar with hardware will be familiar with the 8 data bits, followed by the read strobe, also the write strobe, and the write ready line, that kind of thing. And then the inverse is true for the out FIFO. So the host can send us data, and when it sends us a ready signal, we can then strobe the read bit, or the read signal, and get our 8 bits out. Cyc here, that took me a little while to figure out when I first came to things, and that's, I think, abbreviation of cycles, so clock cycles. And if we have a look down, we can see that the timer will support up to this value. And timers being timers, you count from 0 up or whatever it might be to measure time. So what we can infer from this is that the inhibit cycles given into us by whoever's instantiated us will tell us how long we can wait before doing something. So I think I'm going to break it here. And I'm going to do m equals module again. Did I do a return m on the last one? I didn't. Naughty atty. Return m, there we go. Right, so self, no longer self, m.submodules.bus. We can just delete self and make it m. There we go. The paths are no longer just available, we need to address them, and buses, that's fine, right. So we mentioned earlier that max is no longer the way to do that, we need to do range, count and error with m.fsm. The whole context handling thing in nMigen is pretty brilliant as well. It breaks your head when you first look at this and you're coming from Python and you're going, reading nMigen, what does it do? You're trying to interpret it, and you have to remember that actually it's not running a program, it's constructing a hierarchy effectively, which it then ships off to the toolchain to build as logic. Yep. Static typing versus not. That's another age-old thing that I'm not going to get into today. Yeah, exactly, sorry. I might have misphrased that, but it runs through this, and somewhere else it's maintaining the fact that you've just stepped into a new state machine, the fact you've just stepped into this state, and then we're going to transplant all of these values into here, and it's going to record the fact that you've done these things, and then it sort of produces this tree, I think. That's my expectation of how it works behind the scenes. No wars, please, Esden, no wars. Blue Book C, I'm not sure what you're referring to, but I think I might have that book, and yeah, there you go. Right, so what we're doing here with this readable is saying, is the out FIFO, so that's from the PC out to the Glasgow, has that got data in that we can now read? And the signal has changed, so it's actually now RDY, or RDY. And then to make sure that things are prepared in time, so I think this is referred to as pipelining, but my phraseology might be wrong again. We also want to make the read enable bit set. So out FIFO.R in is equal to 1. So the idea being that as soon as you come into the receive command state, it will set the bit or that signal high, and then on a clock edge, when the ready signal is high, we'll then do all of these things. Just catching up on the chat. Well, other things yell at you if you don't return M, so I don't think it's such a bad thing. So count is going to become out equals, out FIFO.d out, and it's not d out. Oh, is it our data? I think it's our data. And we're going to choose the first 7 bits, is that correct? Yes, I think that's probably correct. We're probably masking it off for some reason. Error equals 0 with m.if out FIFO dot, there's the 7th bit, our data 7, or the 8th bit, sorry. Then we do this, otherwise we do that. So it's a read-write flag. Yep, that's correct. Oh, we need the m.next is write byte. Else. We've got multiple things here, so we can make an array. That state done, I think. got to admit, the underscore versus dash or hyphen in all of these names, it really makes me trip up every single time almost. Just holding the shift down and versus letting it up for one character. Right, again, so sorry, I was just rewording it. So this is actually our ready, and we want to do m.d.comb out FIFO.r enable equals 1. Right, so as soon as we exit these states, so in this state we've set the r enable to high or 1. As soon as we exit that state, that assertion disappears and seems to return the line to 0. I think that's a correct understanding, and I'm not sure if that's nMigen thing, or if if no one's driving the line, does it just idle low, or quite what's going on there, or how it's expressed. I presume it's somewhere though. Maybe it's just the way the signals are handled, and there might be an argument for the signal saying if no one's driving me, go high. It's nMigen, is it? Okay. It's one of those things that I've just kind of gathered, if that makes sense. Okay, so that's why I was expecting it to be not well defined. So we're saying that nMigen defaults signals to 0, whereas Verilog it would be undefined, which is where I was coming from. Is that right? Thank you. Oh, okay. Reset signal versus 0, or reset state. Sorry. There's so much to this to learn and figure out. Right, so we're done with that state. We can get rid of right byte. With m.if. So STB again is one of those little abbreviations which I tripped up on when I first came to this, and it's short for strobe. So if you're doing a read or write to memory, for example, you'll strobe the write line, and that will put everything through the latches and make the state advanced or whatever. Cool, thank you, Omni Technomancer. So it's defined in the signal. Up here we could do reset equals 1, for example, and I guess the undriven state for that signal now becomes 1 instead of 0, which is the default. I would presume, at least, from what I'm hearing. Reading the docs, another kind of controversial thing, I guess. Okay, write check. Let's get rid of that last panel. Writability not checked to avoid dealing with overflows on host controller side. You better be reading from that FIFO, but the FIFO is 4 times larger than the largest possible command response, so it's never a race. Sounds reasonable. So with m.state write check, let's grab that comment. Combinational logic again, and we're going to say in FIFO. So write enable has been renamed to when. In FIFO.d, no it's not, it's data. Ah, nice. Thanks for the clarification there. Okay, so this is another oddity, perhaps. When you're coming from Python, you like to use the word or. If you're in C, you'd use double pipe to say logical or. Whereas in nMigen, because we are We can't use or because that's a language thing, I think, and so we need to use a single pipe to give a logical or. Bitwise or. Thank you. Yes. That looks okay. There are probably a whole bunch of things that I've tripped up on, like the FIFOs, for example, need to be self.in FIFO, so we'll come back and tidy those up. Don't want to do it now and then just make the same mistake again. Oop. LF. Got strobe again. So write enable equals 1, so that's turning it on before the actual clock happens, if that makes sense. So as soon as we step into that state. I think pipelining is the right thing to be calling that. Again, single ampersand, not double. Oop. Exciting, an infinite read. And that probably looks good, there we go. That's interesting. It looks like we are just advancing states even if it hasn't successfully been put into the FIFO. So I'm not sure if that's something that we should consider fixing up. So I would do something like m.if in FIFO.ready. Well, you say that. I quite like making white space tell you things. So I've got all of the white, sort of the write states bunched together, and I've got all the read states bunched together. It's a style thing, and if you feel like that's wrong, then please feel free to say so. But I might not listen to you. Yeah, so I think I'm going to go ahead with this. I'm going to put a little note in there to me. Is this okay? Oh, nice, thank you. State. Oh no, I completely get you on that point. Trouble is when there are single missing space versus more, like on the right block, it's difficult to tell sometimes. I think that's all okay. Final state. Right, that feels good. Oh, don't forget the return M. Return M, and 2 new lines between classes. Right, so we mentioned there are a couple of things to come fix up. The pads we've already dealt with, the in FIFO and the out FIFO need to be fixed. So let's just take care of that quickly. Self-dot that. Boop, 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 boop. Okay, and what else have we got? The inhibit cycles. So that's here. I think it might not be anywhere else. Oh, it is. Self-dot that. Cool. Okay. What do you reckon? Is this going to work? First time? If I had the ability to make a vote happen in the chat, I would. Not sure how many people we've got joining us at the moment, but it'll be somewhere, I'm sure. Never mind. I vote it will work. Thank you, Esden. Thanks for the confidence. See what happens. Right, you can still see the mouse, which is good. Oh no. Okay. So this is complaining about timer in m.d.conf. Well, that's clearly wrong, isn't it? So line 1319. That should be sync. How many more errors do you reckon there are going to be? Inhibit wait, I've spelled something wrong, I bet you. That is... reference but not defined. Let's just copy that so I don't get the spelling correct versus wrong or whatever it might be. Ah, here it is. Inhibitee. Inhibit. Wait. Pads not defined. PS2 host line 110. Okay. That's annoying, huh? Same again here. What else have we got? Pads, just those pads, there we go. IntelliSense and nMigen. 156, bus is not defined, 156, that's going to be self.bus. Any other use? Oh yes, okay. Nope, yes, 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 yes. Yes, yes. There we go. Frame does not have a field raw bits. Where are we looking? Frame to raw bits, line 156. What is a frame? Frame's a record. Ah, okay. Frame layout. Oh, no raw bits. Okay, well that's potentially frustrating. I think this is something that's changed name probably between the two. I think it was a record, wasn't it? Yeah, record frame layout. Raw bits. There you go. So that's a function which gives us all of the bits. And in this world, do we have an equivalent? Shape, connect, no. Who's more fluent with nMigen than me? Do we have an equivalent for raw bits? I'm not sure we do, and I'm going to take this upon myself to write something different. You think you can just use a record like a signal? Oh, okay, so if I just get rid of raw bits and just use it like a multi-bit signal, see what happens. Let's give that a go. If that doesn't work, I have ideas of how to resolve this. So. Reduce is not a word. Oh, what? Reduce is not defined. I thought that was a Python built in, to be honest. It might not be the right reduce though. Reduce is a Python thing, yeah. So if we have a look at the existing PS2, reduce is gone on Python 3. Oh, is it? I thought it was in a library somewhere. Functools. That's clearly the wrong documentation. Oh no, it's not. Yeah, functools.reduce. So I will try that quickly. Is it a bitwise reduce or is it a Python reduce? We are using operator.xor on frame data. I think this is a Python reduce. Feel free to argue with me on that though. And I think this comes from functools. So if we do functools.import, import functools from import that's a thing in nMigen as well, is that? Okay. Functools singular. bit no. 139. 193, sorry. Dyslexia creeping in. Bit is not defined, 207. What do you reckon that's supposed to be then? Receive bit. This is where a diff gets a little bit painful because we've changed so much, so let's just grab the original code, applet in, oops. Interface, PS2 host, init. And what are we looking at? We're looking at the receive bit state. I was going to put it on the other screen, sorry. Oh, bus.falling, not bit.falling. I was clearly not concentrating. Bus is not defined. Well, that's a promising start. What do we reckon? Error. Parity error. Oh no. Signal.xor is also a thing. Equivalent. Okay, I think progress. A little bit of progress. It builds. It doesn't work. So now we've got to figure out why it doesn't work. I'll leave it with python.reduce, and I might come back to that later if that's okay. Parity error in byte 0 to response to command FF. What do we reckon there then? Parity error. So previously we had operator.xor frame.data and we had reduce operator.xor data. Parity. So the top one, verify frame, that should be combinational, I think, probably. And that's not combinational. Well, okay, that's probably fine. It did something, yeah. Whether it was the right thing or not. Next, value. So previously we had, let's put that there, make that go away. So previously we had next value self o valid becomes the output of this function. This function, again, we were talking about the way that nMigen works. It's not calling this function to then get the result and store it here. It's at sort of compile time effectively. It's calling this function which returns us this tuple. No, it's not even a tuple, it's actually three values which are all ANDed together. So we're confirming that the start bit is 0, that the parity is the inverse of the XOR of the data. Is that correct? I'm not sure. And the stop bit is 1. And that becomes a single bit which gets stored into OValid, which is a single bit signal. Let's read some of the words, shall we, about the parity. Ooh. Wow, there's no words about parity. That's a shame. So why don't we just hack this to say 1 for now and see what happens. We might just get loads of data, but it might be completely broken otherwise. Unwritten response FF. Okay. I think that's probably not the fix or the step forward we're trying to take. There we go. A bit of a clean up. So what does reduce actually do? That will... I can't remember now. It's one of those functions which is neat, and once you get it, once you understand what it does and how it works, you can use it over and over. Right, okay, so it gives us that. If the function is x plus y. The function is operator.xor though. What does that actually do? And what does its prototype, or whatever you want to call it, look like? AB, return the bitwise exclusive OR of A and B. It's a fold with an implicit accumulator. I'll take your word for it. So frame.data is 8 bits. And it takes, I think that is an iterable, so there's 8 bits in there. And it goes for each bit in data, I'm going to give you 1 plus 2. So it gives you the first 2 bits and you say XOR them. And then it takes the result of that and gives you the third bit and says XOR the result with the previous. And it keeps going until you've got a single bit out. And the result of that then is pretty much as we have here. It's this, but it's actually XORs in each of these places. Check if there's an XOR method on signal. So what I would do, frame.data.xor, do you reckon? Let's just dig into it, come on. Oop. Oh. Init. And signal comes from AST. This is really not the way to do it. Oh, AST.py, of course, okay. Right, so signal is here. There you go. Okay, so we've got a like a shape. We might inherit things from a value. I reckon values in here. Oh, come on. There it is. Excellent, there you go, okay. Pairwise exclusive OR for every bit. 1 if an odd number of bits are set, 0 if an even number of bits are set. So that's exactly what we're after. Let's just use that. Good call, thank you. XOR. So we want the inverse of that, which is fine, but we just need to be aware of it. And same again here. Data.xor. Not fully sure this is actually going to work, but give it a go, certainly. Ooh. Parity error in byte 0. Let's get rid of operator, get rid of functools. Yeah, I think you're both mentioning it. I should have taken you up on it earlier. Let's get the logic running again. Oop. No decode. Wonder what's going on there then. Okay, let's just run through this applet step by step, checking that we are happy with what it previously had in it. Versus what we've got now. So the bus. This is where it gets frustrating, I'm afraid. So we store the pads, falling, rising, they're all the same. So the module then has combinational logic. The clock output is disabled, is 0, and the output enabled. So these are active, what's it called? Open drain IO. And same for the data. So if we try and write data to the, if we try and assert the data line, then it will be pulled low, otherwise it will just be left to float. And I think that matches up what we've got here. ffsync saying, yeah, I think that's okay. To be honest, not much has changed in this module. ES2 host controller. What do you reckon? I'm a little bit suspicious of the record in a way, but I'm not sure. The VCD trace gives us the same thing as the CLE logic probe, I think. I might be wrong. It might give us more. I guess it might give us the signals between the modules. Should we give it a go? Oh, is that true? About the signals, though, sorry. Respond to something specific, Atty, come on. Let's have a quick look at that. So, range 12. Well, if you call range 12 in Python and enumerate it, so if we do range 12, we get 0 through 11, don't we? Right, start expressing here. Yeah, so I could give it another one. I think it probably would complain somewhere, maybe. But no, maybe not. Oh, but no is equal to 12. Yeah, okay, so it probably can't actually store 12 in it. Let's give that a go. I'm gonna rebuild it anyway. Max is exclusive too, is that okay? Still doesn't work, I guess, so I think I updated that to 13, yeah I did. So in here we get bit nose compared against 12, and it starts at 0. So I think that we probably do need range 13. But as you're saying, it's going to turn into a 4-bit value anyway, so that probably shouldn't do us a problem, should it? So here we're doing frame robit 0, and here we're doing frame 0, which I'm fairly content feels like it should be the same thing. We could also have a quick look at that VCD file. Yeah, sorry, I didn't do anything with it. Let's get, what's it called? Yeah, this one. Can't do reading, can't do reading. Yeah, so we do just get the signals at the edge. So output enable, data enables nothing. Data I/O. How does that compare to what we see here? That feels like it's truncated, doesn't it? Do you reckon our data isn't working? Feels like it's trying to assert that signal, but we're not seeing it on the logic analyzer. Am I reading that correctly? Let's investigate that. I think that's reasonable. Then here we see clock OE, data OE, clock IO, data IO. I'm not entirely sure where these come from. Oh, are they the pads on the pads that have... No, they're not though, are they? Okay, I don't know. So, current hypothesis, for some reason, is that there's a command that the Glasgow is trying to issue to the mouse, which is not coming onto the line. We could turn the analog channels on. Just see if that helps at all. Whoop. Stop. Okay. No. Okay. So in this kind of situation, what I tend to do is back off a bit. Because we are importing symbols into the Python environment, which are conflicting, overriding with each other between nMigen and nMigen.compat, we can't put modules of the same type into one file. So I'm going to put copy init.py into nMigen.py, and in here we're going to delete all of the applet specific stuff. So applet error, ps2 host interface, ps2 host applet, and a test case. And we're just going to have our nMigen resulting applet, or modules, sorry. And then what we're going to do is git show, where are we? Git show head, software, init py into compat.py, and we can do the same thing. So this is our before change. So we've still got the nMigen.compat here, and we're going to just remove all of the applet specific stuff, just like that. There we go. And now what we can do in init is import a specific thing from one or the other. So get rid of these, get rid of this, and this. There we go, down to there. And we're going to just pick out specific things. So if we have a look at compat, we're just going to take everything from here to begin with. So I think we can probably go from compat import ps2 bus, from compat import, and then the next module, which is called ps2 host controller, from compat import, and that's going to be ps2 host subtarget, ps2 host subtarget. Okay, so now if we run that, we should be running the old code. Let's get rid of that trace just because it takes a little bit of extra stuff. No. Compat, I spelled that completely wrong. Compat, there we go. Found 5-button mouse and it works. Okay. Error, parity error. Just ignore that. Okay. So it's a little bit dodgy there. I'm not entirely sure if there's dodgy connection or quite what's going on. There seems to be a pretty massive delay between my camera and the stream, or is that? Let me have a look at the other thing, sorry, one sec. Yeah, let me restart that quickly. I've got a Raspberry Pi Zero I got the other day to do this overhead camera. If I do that, it should kill the video. There we go, and if I do this, it should bring it back. Maybe. Come on. Right, I'll see if that's going to wake itself up. In the meantime, we can carry on with this. So we've got the various compat things. Now we want to just swap them out one by one, basically, for the rewritten nMigen stuff. So we're going to pull out this bus because, not that bus, sorry, this bus, because we have high confidence that that's going to work after our port, or our rewrite. So from nMigen import PS2 bus. See what happens. Still no video. Right button mouse. Right, so we've now proven that our bus is correct. And that's nice. What does that cover? Where are we? That's the wrong thing. nMigen. Right, so we've proven the bus is correct. That's just the raw signals, so there's none of the record stuff going on at all yet. Now we want to swap out the PS2 host controller, which is just used there. So from nMigen import PS2 host controller. What do we reckon? Is that going to make it spring into life or die? There you go. The host controller is potentially our problem. Could be something in the state machine or anywhere really. I think my current suspicion is this record stuff, to be honest. Don't know why. Let's keep going though. Oh, is there another to-do we put in? There was, wasn't there? Not in this module though. Okay. Feel free to shout if you spot it. How's our prepare frame looking? I think that looks okay. Moving on to the send bit plate. Bit knows 12 again. So we got, let's think about this, we've got bits. We've got 8 bits. We've got a start bit, a stop bit, and a parity bit. That's not 8, that's... So that is 11 bits that we need to shift out. So I guess 12 is just 11 plus 1, isn't it? Ah, look at that. Bitno 1 versus Bitno 11. Oh, thank you very much. Good to have you along for the ride, and I'll maybe see you again next time. We're want to stay and see if this will work, or have you already gone? Oh, look at that! Woohoo! Good job. So yeah, that was my typo. Apologies, everyone. I put a 1 instead of an 11 in there. Yes, woo indeed. So I think we can probably put all of this into the top of the init file now, and it should just work. Wouldn't that be nice? Plop it there. Ooh. So if I remove, or at least move out the way, compat and nMigen, and run this again, see what happens. Should work. Looks promising. Woohoo! Look at that. So these parity errors, be interesting to see if the logic analyzer picks them up. I'm not entirely sure what's going on there. I suspect it's a naughty mouse. Oh, the logic analyzer is completely out of sync. Look, that's annoying. Not sure quite how you get it to behave a bit better. Yeah, it works. I mistyped a number. I put 1 instead of 11. Apologies for the frustration incurred. So there's no way of resetting this or telling it to not start the analyzer until this point, for example, which would be quite a nice feature, to be honest, but yeah, never mind. The parity error I am going to put down to communications or mouse or something. Screaming at their bud? Who's that then? Not me, surely. Left button, right button, ooh, middle button and left button. Lots of X, Y's, mouse wheel, -1, ooh, +1, -1, there you go. Yeah, that's true actually, you can put an edge trigger on there. So what we're going to go for? I think we really want to trigger, well, let's trigger on the rising edge maybe, just see what happens. See if we can make this parity error happen, there we go. Oh, that looks much better, well done. Oh, the future VOD watcher, yeah. I can just skip ahead a few minutes, or half an hour, or however long it's been, I've lost track. Oh, it's 1 o'clock, no way. Right, so parity error, we've got a parity error all the way down here. Oh, that does look like a parity error or something, doesn't it? What does that tell us? Mouse data 02. I don't read PS2 well enough to kind of get into the details of that, but there's a red cross there, so I'm going to go with it's not Glasgow's fault. It might be the mouse's fault, it might be signal integrity, something like that. We can just pretend it doesn't exist, I think, for the moment though. When you want it, you can't get a parity error, look at that. There we go. What does it look like at the end here? Oh, it's not even decoded that frame. Okay, never mind. I think we can call that done. It works. It's now nMigen. We can get rid of the X. We can add this and just sort of verify that it looks reasonable. There was something we changed. There's a nasty thing there. Let's get rid of that. I think there was something we changed where I was going to put a to-do. Oh yeah, this to-do here. So something worth doing potentially is just verifying we get a parity error before the conversion as well. So what does this look like now? I think that looks okay. What are we going to go with? Applet.interface. Oops. PS2 post, I think it is, yep. Convert to nMigen. Great, I'll take care of that later. Should we have a look at the VGA as well? I'm certainly keen to have a play with it. Whether or not we actually get it converted or not is another option, or another question, because we've got not much time left this evening. I'm getting a bit tired. VGA output. It's VGA terminal as well, look at that. Oh. VGA output. What does it look like? Is it big? Okay, so it's a 6-color simple VGA interface, and the applet is not very big. What do you reckon? Should we go for it? Oh, we were going to, sorry, I've just completely forgotten. We were going to verify that the interface PS2 host. So if we check out master and just verify that, we still get the parity errors, or that trip up unsolicited response before the nMigen conversion. There we go. Yeah, we do. Okay. So I think that's okay. We can leave that. Okay, VGA output. I have no idea what to expect from this. It's possibly just a test pattern, is it? 640 by 480, 60 Hertz. So you've got all the timings and everything, but I don't see any way to give it something, like an image to display. Just an output test pattern to VGA. Okay. Yeah, why not? How many people have we still got watching? Viewers? 8. Okay, that's cool. I'm happy to keep going for a bit. This one might be a little bit more awkward to share with everybody. I've got, from the ye olden days, I've got a nice, just grab that back. Sorry, I've got a nice VGA extension cable which I'm planning to just poke these DuPont cables into. We need to find the pin out. I've got a VGA monitor up there which I'm going to turn on, but I won't move it, I think, if that's okay. So you'll have to take my word for it. I might be able to point the Raspberry Pi camera at it when we've got something happening. I'm going to need a long power cable. Which I keep handy. What can we steal power from? This. In my headphones. Right, nope, underneath. Actually, I'll just bring it down. It's gonna be easier, isn't it? I haven't used this screen for so many years. There we go. Right, I'm going to put this, I think, probably on a stool just over here, so that you might be able to see it from the camera that's on me. Do you reckon you can see that? Yeah, that looks good. How's that then? That'll do. Hopefully you're okay with all that. Okay, so let's... Oh, the Raspberry Pi camera's not working still. That's annoying. just get rid of it quickly. Okay, I was going to show you the connection and removing of the mouse and things, but I'm just going to do it because the camera's not here. So that was cool. Thank you for joining with the mouse. Now we're going to need the VGA cable, and that requires, according to the docs, 5 signals plus a ground. So I'm going to get my trusty box of cables, break out a few new ones. So if we go for these, 1, 2, 3, 4, 5, 6, I'll do. Is the Pi camera going to come back? It's responding to pings again, which is good. Rebooted. No. Oh, there we go. Yay. Okay. Welcome back, Raspberry Pi. So we got the A channel ground in there. We don't need VCC, I don't think. It will, I think, tell us probably somewhere what voltage to use. Yeah, so if the port voltage is set to 3.3 volts, these resistor values are correct. And these resistors go via these pins. Actually, I could have used these ones instead. Is that 5? That's 5, there we go. Right, and another thing that everybody should have is a box of common resistor values. These kits are brilliant. They just have sort of a little baggie of everything. I mean, not literally everything, but most things. So we're looking for 100 ohms and 350 ohms. That's not it. I'll just go through these quickly. So 100 and 350. K, going to be right at the bottom, aren't they? 150 ohms, that's close. 270, that's close-ish as well. 220, no. 100 ohms, there we go. 22, 10, 330, I think that'll do. We'll have a 330 ohm resistor. Just put all these back in the box. Kind of annoying, the box these came in only just fits them all in if you pack them really carefully, so I will do that later. So 350, but we're using 330 ohm resistors, which means we'll get a slightly, what will we get? Slightly higher voltage than normal, but I think we'll probably be okay with that. With them. And 2 100 ohms. So the way this will work, I think, is yeah, just full on off, and so you get no colour. You just get so if you have a red RGB LED and you are just to turn the red on but the others off, you get red obviously. But if you mix in red and blue, you get the sort of the turquoise, sort of pinky colour. Turquoise, that's probably the wrong name, isn't it? I'm not very good at my names. So yeah, there's no DAC in here. It will just be wiggling the lines to their full sort of rail to rail, or not rail, but 0 to 0.7 volts. Or at least that's my expectation. We can have a look at it. So we're getting 0, 1, 2, 3, 4. So if we go for these there, let's turn the outputs off actually. Oh, I can push my button, that'll do. Okay. Alright, bring that into shot. Apologies for giving you something a bit boring to watch for a minute. Oh, I've got the wrong wire on that. Let's steal this one. Just going to swap that one out. Okay. So if we look up the pinout for the VGA connector, these DE15 connectors, what do you reckon? VGA pinout will probably do the job. That looks good. How about this one? Are we going to need to put a ground into multiple pins? I don't know what that means, and I'm pretty sure that's not right. Ground goes to pin 10. Oh, and the others are shields, are they? Let's look at the Wikipedia page. Yeah, red return, green return, blue return. So I think if we're going for just, I've mixed up my resistors. If we're going for just 480p, I think we can probably get away without too many returns. Let's just verify that they all are connected somewhere. So I'll turn off the screen. Multimeter into beep test mode again. Beep. And what we're looking for is, so 6, 7, and 8 are the returns. 6, 7, 8 are over there. 6. So are they actually connected somewhere? Yes, and I don't really care where they're connected, just so long as they are connected. If you have a higher resolution, then it becomes more of a problem. I think that, okay, cool. Who remembers VGA monitors with horrible ghosting and ripples across the screen from high frequency signals like text, for example? Black on white, that kind of thing. Okay. What we're going for then is, just zoom in on this bit over here for you. So pin 1 red, pin 2 green, pin 3 blue. So those will be the, what were they? 350-ish ohm. I think they went for 330 in the end. I'm just going to poke them in. This is not going to go well, is it? Let's go with these pins. Red, green, blue. So I'm just poking the DuPont cables into the end of this connector because, I mean, it'll do the trick, I think. So red, green, blue, ground is on pin 5, for which we have one of those. Swap out that, so. Oop. I can actually swap out that ground because we don't need to go via a resistor for that. That's the thing, yeah. I think with the Glasgow we probably got enough to do at least a few values of well, you know, colour depth wise. So maybe that's an improvement we could suggest for the some time to come in. Okay, then the syncs, H-sync, V-sync are pin 13 and 14. So they are down there, 13, 14. Yeah, there are quite a few things which make use of resistor ladders or whatever you want to call them, DACs, for driving things like VGA, because I think it's, yeah, I mean, if you're doing smallish resolutions like retro consoles and things, then not such a big issue in a way. Let's get this back. So we are going to go with H-sync on pin 0. It's 3 colour, but don't forget you can mix them in any orientation or any combination. So I think it's probably 8 colour. You got black, red, green, blue. That's 4. Then you got cyan, magenta, and yellow-ish, and then you got white. So that's 8 colours. So H-sync pin 0. Pin 0 is going to be green. Green gets one of these resistors. Like that. And you can, with these DuPont connectors, you can often push them past. I'm not sure if you can see that on stream, but you can kind of push them through and through. How can I make that more visible? There we go. And they hold really nicely actually when you do that. But when they're just sort of halfway into the connector, it's not great, to be honest. Right, so H-sync goes into pin 13. Pin 13 is the middle bottom one, which is yellow, like this. There you go, yeah, thank you. H-sync, V-sync is going to be blue. I'm just going to make sure none of these touch now. And that's going to be white. Like that. Bend them away. Talk about a yucky setup, eh? Right, brown, red, green, blue. I think I did these in brown, green, blue. Red. Oh no, I did them upside down. Let me swap them because then that'll be a bit nicer. I think we may also have to do something, red, green, blue, may also have to do something with the display to make it wake up. And I think that might be shorting 2 of the pins on this connector, because it is a little bit asleep at the moment. Right, red first on purple. Goes into brown. I could use a proto breadboard, whatever, for this, but oh well. I didn't dig one out before the stream and I'm not going to go digging now. Red, green. Blue. So do you think this will wake up just on the syncs? Or do you think we actually need to make it wake up by doing something? I really don't want to talk EDID or anything like that. Or DDC, sorry. Okay. Okay, I think they'll look alright. Let's just separate them a bit more. I'll do. Don't look too closely. Might fall apart. Okay. So, what do you reckon? Pixel clock frequency has got a default. They've all got defaults. All the porches and timing and everything's got defaults. So let's go with 3.3 volts. I don't think there's anything else to do. You reckon giving it a valid sync, make it light up? Oh, look at that! Brilliant! Can you all see that again? I like it. Oh, now you're underneath that. There you go. Okay, so we got a nice test pattern, and we got black, red, green, yellow, blue, magenta, cyan, and white. And here is exactly what I was referring to about the yucky stuff. So the white to black is what's known as a high frequency signal, because if you look at the analog signal as it scans across the line, it goes very suddenly from 0 volts to the 0.7 volts. And sometimes you get ringing on that, and sometimes you get sort of a bit of bleed. So what we actually have here is white to kind of a gradient of white to black. If you'd like to see closer, I could bring you closer perhaps. Just bring this to you this way maybe. Is that going to work? No, but there we go. Yeah, there you go. So you can see here, we've got white followed by a black square, but actually that's a real gradient and it's not subtle in to the eye. This one up here is nice and black because that's after the porches and the blanking, so the signal's already low. And then at the top, the very top, you can see a little bit of tearing as well where the sync signal's not quite right. In fact, that tearing is on the top of all the blocks. Anyway, so that's cool. Got VGA. I'll just pop that back down there. And that's what we're aiming for. We can press the button and get some timing information. So it does recognise 640 by 480. I don't think this screen's going to give us any extra information about the timing though. No. Never mind, that's fine. I'm happy with that. A free gradient, yeah. Okay, I think this is a nice small applet, so let's just go for it. Everyone okay with that? How long have we been going? 2.5 hours-ish? That's fine, just a little bit longer. Okay, here we go. Nice to see there's nothing special going on in this applet, so there's no like FF sync or multi-reg or whatever you want to call it, and this is just a test pattern, so we could feasibly rewrite the test pattern to give us color bars or something else, which could be quite fun, but let's just do it as is, direct rewrite, and go from there. Oops. Okay. You're not watching the right thing, apologies. There we go. Nope. Nope. There we go. So what I was saying earlier about the interface between modules, these signals here, the HSS, the syncs, the RGB signals are between modules, and then that is good to go. We actually need to do a module and then a m.d.com and then return it. Good. I think that's done. Next. So this one's got lots of arguments, a little bit more complex. I think we're just going to keep hold of all of them. What do we actually do with these? We are using these in this module specifically. This is the VGA output, the first one that we've just completed in about 10 seconds, is just the signals and how to present them to the line, to the wires. So could we do anything a bit clever with these syncs and things? It, for example, is the H sync actually used elsewhere or just in the total? It is used elsewhere. I suspect it probably would be. That's fine, let's just keep everything. you are. Let's do this with a brain on. We've got H front and H sync. Oh, too many tabs, never mind. Oh, I see. Tab versus 4 spaces. Let's go for not a space. Self dot that equals that. That'll do. Turn off highlighting. Cool. Okay, module m dot sub modules dot output equals VGA. Self dot paths. Okay. So we are doing clock domain type stuff, and we're using a PLL here to clock up from, what was it? Oh, the default clock's 25 megahertz. That's not so bad. So actually, we're down clocking from the Glasgow's 48 megahertz down to 25-ish. Oops. Oh, okay. I have done this before, but I can't remember how to do it. How do we deal with clock domains in nMigen? So that's platform dot sysclock frequency. Right, I did another PR recently that dealt with that. Can I remember what it was? I think it might have been this one even. Yeah, platform.default clock frequency, there we go. Which means that we don't need to pass it in from the applet anymore. From the applet. So we can just pop that there. And the pixel clock frequency needs to come, but the sys clock frequency does not. And I think we can probably just about get away with unwrapping that. Each of these get a self on them. Self. Let's do. No, yes, no. So these are just signals now, and we can just get rid of these self dots. The record, I think we were okay with when we in the git logs. What are we working on? We're working on PS2 host. Do we have to do anything special for the record? We have to import it, that's the one. But otherwise, I think it's the same interface. So these strobes are, they are actually strobes, they're not the sync pulses that we send out to the screen, so that's fine. And this is where the clock domain comes in. Might have to look that one up. So that becomes from nMigen.hdl.cd import clock domain. I suspect this is wrong as well, but we can just carry on as if it's fine. So the n.d is accessing the clock domains, and combinational logic it's not really in a clock domain, it's just is what it is. So that's always in comb. And then there's the default clock domain, which is m.d.sync, which is all synchronous stuff. But I believe we can do m.d.pix will access the pixel clock domain for us. So instead of sync, we're using pix here. But actually what we want to be doing is using an if block. Sync is the default, yeah, that's correct. Omni Technomancer, have you got any insight into how we put clock domains into the nMigen modules? I can't remember how to do it off the top of my head. Looking at the top of the screen up here, the to-do. So these CTR abbreviations, I think, are counters, having written that out. So we're counting across the vertical and then multiple times across the height of the horizontal. Oh, sorry, other way around, yeah. M.domains, is it? Cool, thank you. .pix as well. Let's give that a go. We can always have it fail on us. That's fine. So we've done this one. Oops. Now with m.if. The horizontal counter is 0. H-enable is an internal signal. Oops. So what we have here is a little block which will count across the horizontal scan, and at 0 it will turn on the output, and then at the end of the horizontal active it will turn the output off, and then once it reaches the end of the front porch it will turn the sync on, and then once it reaches the end of the sync duration it will turn the sync off, and then there'll be another duration after that, which is the back porch, before it starts that all over again. I could draw it out if people are curious or not quite following my words. keep putting these self-syncs, I'm just typing it direct. And these actives I think are, yeah, they need selfs on them, so I'll come back and fix that up. Ah, yeah. So there's the horizontal and the vertical counts. And now we just do a little bit of magic to produce a nice pixel color. How does that work then? So if the horizontal counter is the horizontal total minus 1, then I don't quite follow, but that's fine. We can come back to that. What do you think? Okay. I think let's give it a go like it is at the moment, and we can come back. Okay, that should be everything done. Need to return M, of course. 2 lines. Yeah, it's very easy to just copy, isn't it? It's the best way to learn, I think, as well. Find something and tweak it until it works for you, that kind of thing. So a lot of these are missing self dots in front of them. I need to remember what is missing a self dot. Not the outputs, but all of the timing information is missing. Ah, that's annoying, okay. No. What is something I'm going to need to come back and fix up? That is a self.v counter here. Okay, what do you reckon? Fingers crossed? Syntax error, line 112. Oh, no commas. Elaborate is not defined elaboratable. Elaborate. That looks wrong. I'm going to get rid of that E. No object CD pix on 197. Okay. Add clock constraint. So oh, sorry, missed your comment, but yes, thank you. So now we are over here trying to add a constraint to that clock that we've produced over here. I think for now I'm just going to turn it off, see what happens. There's a self.comb somewhere, subtar.comb 200. Oh right, so here's the test pattern. Clock constraint is how that signal is assigned. Do you think? Okay. Is it worth looking for something else that uses a PLL? Just in the applets. I'm sure I've played with one of these recently. Maybe it's in the gateware. Oh, let's have a look at this. No, maybe not. Yeah, so I think we are importing something we don't actually need here. Let's get rid of that and deal with it later. Oh well. So I think this constraint here is more about making sure it doesn't run over too far. What was it? Something just the other day. The way it is, isn't it? Constraint. I'm pretty sure there's the word constraint in it. Oh, is the audio, the DAC. Audio DAC in it. Here we go. And this has got a sigma delta channel and I think it's here. Here we go. So we derive a clock. Okay, that's max deviation, and that produces a number which you count up to. It doesn't actually use a PLL to produce a new clock. Okay, let's ignore that one then. Bad memory. Line 200. So subtarget is going to be, I guess, subtarget.m.d.com subtarget pix. Okay, so here's where we should have put the pixels in here, because they are actually referenced and they're part of the interface with the applet, or the widget, sorry, applet. Wrong names. Same again for the horizontal and the vertical counters, because they're used to generate that signal. So what we can do now is pix self dot that. I got it wrong. Okay. Get rid of that one. No. Nope. Yes. Okay. Oh no. Oops. Okay. These picks do actually need a self-dot in front of them. Yep. H total. Oh, we got a max in there. We need to get rid of them. Oh, and the totals are needed up here as well. What do you reckon? No. Okay. Output subtarget has no attribute D. I think this might be a little bit of a rework required. Line 201. What does this actually return us? I guess it's not the module which Elaborate produces. Oh, sorry, the error message for the constraint. Let's have a quick look at that. It has no attribute CD picks. Well, get rid of the CD because we didn't actually end up using that. And it might be d.picks.clock. No attribute D. Picks doesn't have a field clock. So the subtarget here appears to actually be the class itself. Okay, thank you. Let's have a look at that quickly. Oh, come on. Okay, so Glasgow abstracts quite a lot of this away from us, and the PLL is actually produced by some of the generic gateware. So MD submodules PLL, and then the clock constraint goes directly on the platform with the clock. There are actually two outputs here. Ah, is this what you were talking about earlier? Sub-target domains pixel clock. Let's go with that. That sounds very promising. There's no attribute of domains. So I think if we were to print that sub-target, what we would get out is actually this class. I don't think it's the result of the elaborate, if that makes sense. Let's just do that quickly. Oh, it is a transformed elaborate. Okay. So I guess we could do a good old for k in the subtarget equals get attr. This is yucky, but there we go. Yeah, so we're kind of, there's the elaborate function. So we need to call elaborate and get its results before we can have a clock domain. I kind of feel like I need to have a rummage, because I think this is not far off something I did see the other day, even though I stumbled into whatever it was just now, the audio DAC. Same again here. We can't use the subtarget to produce the pixel outputs because we haven't elaborated it yet. So maybe this is something we need to do at runtime. Can we do that? Let's just do this again for iFace. Apart from we don't get that far yet, do we? So just turn all this off. Could do, in terms of creating the domain and the init. There's no age total. Oh, right. LF 94, lots of typos tonight. What do you mean does it do to the VHDL? Aha. Ooh. Black green. It is synchronized and there is noise on it, so we're just not generating the pixels. I think this might be the right sort of place to be doing it. In the run rather than in the build step. Oh, look at chat. Saves 2 chars. Move the constraint to elaborate. I think that's not a bad idea. And same again probably for the test pattern, at least for today, just to make this work. Python does elif for maximum typing speed. Yeah, so let's move this across. Pixel clock frequency time, so that comes in as pixel clock frequency, so we can use that again. Let's get rid of these things. And this, I think we just say yes, the test pattern is always happening. So that's m.d.comb. Subtarget is no longer true. It's now self, I think, yep. And then for the clock constraint, let's just try platform to add clock constraint. m.domains.pix.clock self.pix clock freak. And that needs to then go underneath the PL. And I'll put this at the bottom. Right, what do we reckon? What do we reckon? Now attribute pics online. Don't know, but it's probably this one down here, isn't it? Looks okay. Oh, it's on the clock constraint. mdomains pix clock. Domains.pix. Let's turn that off for tonight. What do we think? Chances of it working? Hey, look at that! How exciting! mdpix might work. That's a very good point. Let's do that. mdpix.clock. No clock in the pics. I think it probably is domains.pics.clock, but I can't remember, so I shall have to leave it at that for tonight, I think. So that's awesome. We've got the PS2 stuff working, and we've got most of the VGA stuff working. Turn that one off and you can see it a bit cleaner. We've still got the same sort of gradient that we were seeing earlier, and actually there's a bit of red creeping in there as well, but I don't think that's different to how it was before. And if I play with these wires, I'll probably get some slight change going on. You hug one of them, for example. But yeah, there you go. That's not bad. I think I'm probably going to call it a night. Woohoo! Thank you for everybody's support. It's always a fun learning experience to do this kind of thing, isn't it? It'd be cool if we could, at some point, for example, take the VGA applet and re-implement a part of it to give a new test pattern. So at the moment we're using the test pattern here. Oops. Can't wait to hear. What's she going to say? So if we change that to 3 and 3 instead of 5 and 5, that may well give us a different pattern. What do you reckon? What do you reckon? No. Yes! Even tighter. Wicked. And the black doesn't even go black, apart from the very first pixel or square from each line. Ah, yes, yeah. Cool. I think that's a good place to leave it for today. Thank you everybody for joining me. Oops, that was not the way it works, but never mind. Yep, so I think done for this evening. Very good result, and hopefully I'll see you all some other time soon. Not sure if there's much else to say, so from me that's a goodbye.